Hello, I welcome you all to Stanley's Online Chemistry Solutions today again. So today we are looking at rate law. We want to solve a question on rate of reaction. Now, the question said the time taken for iodine to be liberated in the reaction between sodium thiosulfate and hydrochloric acid at various temperatures are as follows. At the temperature of 25, the time taken for the reaction to go into the time that the reaction proceeds at is 72. At temperature 35, there was a reduction in the time of the reaction proceeding. The time of the reaction is 36. At 45 degree, as the temperature is rising, the time of the reaction is now 18. The forward reaction is now what? 18. So if you look at it now, you observe that as the up one is increasing like this, the down one is decreasing. That means as the temperature is increasing, the time is decreasing. Now the question is asking us, it said this result suggests that for a 10-degree rise in temperature, because this temperature is increasing by 10 degrees, if you look closely, for a 10-degree rise in temperature, rate of reaction is doubled. Is that what you can find here? B said for a 10-degree rise in temperature, rate of reaction is halved. Is that what you can see? C said time taken for iodine to appear does not depend on temperature. Is that correct? We'll find out. D, for a 10-degree rise in temperature, rate is tripled. Right? So what do we choose in this answer? Now, if you remember now, this reaction now, we want to extract iodine to come out of this solution between this and this, right? So one thing that will be done is that potassium iodide at a point in the reaction will be added to this solution to facilitate the coming out of what? Iodine, so that iodine can be liberated by oxidation, whereby the acid will be oxidized iodide to iodine, right? Now, how do we now get, if we follow by the data given to us, we can say that what we are seeing a halving process, halving, like half, from here to here, here to here, here to here, right? It is halving, 72, 36, 18, halving, right? But even though it's halving, what is halving is time, right? Remember, the question is suggesting to us, in the suggestion from where the question based, they are asking us of rate. But what we are observing that is halving is time. Does rate and time mean the same thing? In this topic, remember that rate is what? R is equal to what? R is directly proportional to, inversely proportional to what? Time. Right? Because the rate of reaction is directly proportional to what? Change in a particular substance, either in the product formation or in the reactant finishing over time. You remember? That is rate. That is rate, but so that means rate is inversely proportional to what? Time. So if rate is inversely proportional to time, inverse proportion means when one is going down, one is moving up. So if the data is telling us that time is being halved by any 10-degree rise in temperature, the temperature now is a constant process, a constant change in temperature. So the time is halving. Now if time and rate relate by inverse proportionality, that means as time is halving, rate is doubling. So if you have now that time is 2, if you have that time is 2, rate will become what? Rate will become what? 4. Is that correct? So the answer is what? A. For a 10-degree rise in temperature, rate of reaction is doubled. Because of what? Time is what? Halved. Now if you choose B, it becomes what? Wrong. Because of what? B, the data showed us that the time is being halved, right? That means the reaction is proceeding fine, but the question is on what? Rate. And there is a relationship between time and rate. So time does not mean rate, but time and rate have a relationship.